I'm good. I'm good. How is a pathology project work for you guys going? Uh-oh.
Mine's going pretty good. Finally got in contact with my project buddies, and we kind of like already got it done. And I think
Good,
the next,
good,
yeah, I think the next step for us is just to practice our voiceover, and we're ready to go.
good, good. Did you upload a presentation draft for me yet?
No, was that supposed to be this weekend on Saturday or yesterday?
Uh, no, I extended it to the 24th.
Okay, yeah.
As soon as you guys have something, upload it for me.
Okay.
Either as a group, which I like you to have, it's a group presentation at the end. And so then it's just uploaded in the Canvas as a group, because it's a group upload. And then I can start giving feedback and going back. Generally, the feedback, honestly, is increased pictures and decreased text. Mostly what I give, if the content is pretty good already. And when I work through material, I often work through it as going over and over it again to like create the video, like visualize how I make the video, how I teach it, not even make the video, how I teach it. And so as soon as you have something, please put it in my inbox or upload it, or you can also email it to me, but upload is the easiest, I think.
And the draft, you want the whole thing, the voiceover, the whole presentation together, right?
No. Just give me the presentation draft.
Oh, okay, yeah.
No, do that before the video, because then we do step by step. I don't. Otherwise, it's all at once, and generally, it's helpful if I give you a little feedback. Some people are ahead of the curve; they are fine doing everything. But sometimes, most of the times, it's helpful to go back and forth a little bit.
Okay. All right. Thank you. Yeah, I appreciate that information. Thank you so much.
No, good. It's one of the points I wanted to make sure, because I only received a couple so far that I went through, and I need some more material to work through it. Also, that I don't have everything all at once next week, and because then after that we have some time to create the video, and then we do the discussion on that. So please, everybody, as soon as you have a draft presentation, you did some thinking on it, you'd like some feedback, a little guidance, put it up, upload it. If it's only you personally made the presentation, you didn't put it in a group yet, send me maybe a text and put it in a pronto or in a Canvas email, depending how you work or where you're working on. If it's the whole group presentation, definitely put it just on Canvas and upload it, and I go through it and feedback on it. No, because what I've seen so far is fantastic. I like it a lot. Okay, what else is there with the thing? And then as the presentation goes, we will use Zoom to create the presentation. You go, I don't know how to show you guys how that functionality is on Zoom, through Zoom, but on Zoom you have a screen, the functions you need to be learning or understanding as maybe as a group go onto the Zoom room that I created on the homepage, and just go into that Zoom page there and play around with it, with the functions you need to learn and know where they're at, and are the recording function, and then the screen sharing function. And then you all want to have the presentation up on your screen, go to Zoom, and then whoever talks shares their screen, and then the video is made of that screen, and then that should make a pretty cohesive way of presenting it, I think. So if you have questions with that, play around with it a little bit within the group, learn the technology a little bit if you don't know yet, and during this next week or so, get to me and let me help you if you need help with that. Okay, should be quite straightforward, but just make sure everybody is on the same page. Also within the group, make sure all your group members are on the same page, not that then you want to start doing a video recording and you realize they don't know what you're talking about. Okay, because it's not it's kind of, we just have to help each other out with this technology stuff. But it's really cool stuff. So we want to take advantage of, and the more we can help each other get better at it. And that goes for, also making presentations. Partly the reason why I want to give you feedback is to not that I think I know more how to make a presentation, but I've learned over the last 10 years how to teach this material, and I've learned stuff with it. And I want to give you as much feedback and as much on your way in that process as I can. Because it's not that hard, and I hated in this college process I didn't like making presentations and always wondering what am I supposed to do, and how am I supposed to make it that it's good and all that. And I'm a little anxious on that front, but that's partly why we're doing that. And so if you feel like you want help, if you feel like you need support, reach out to me, get me in the conversation, so I can guide you and do that with you. If you're already cool with all that, hey, better to you. I really love it. The stuff I see from some of you, I can learn tons. Okay, so this is, at the end of the day, a process of helping each other out, making, teaching each other about some research we do. That's really the point of it. All right, any questions, comments, or improvements on that process from you guys then?
Yeah, just a question. We're doing voiceovers on the presentations, or is it?
Yes.
Yeah. Okay. So we're reading all the stuff that we're writing in there. Okay.
Well, yeah, and that's a good thing. The question with that, of course, then becomes of how do you do it? Do you just read it, or that, mainly I'm asking you to put more pictures in.
Right,
and less text. And when I make even now, I've been texting, I've been publishing it a little bit late because I've been texting for the websites, what comes next in the next chapter, and I have to go over and over and read it again and again and visualize you reading it as the first time what I'm trying to tell you about the next chapter, that you get a little bit of an idea within 2 sentences. It's a process, it takes time. And so do that process with your presentation. Don't just do it last minute.
Right.
And don't spend 15,000 hours one time. Go back next day, because or when you reach your limit and you say or a block and you go I don't know what else, then stop it. Go do something else. Go back. I've learned over the time, if I give it a day or two, or actually a day is usually fine, and I go back read it, it's I see so many new pathways opening of how I can make it better than if I do it 5 hours at a time. Unmute. Sound unmute.
Oh, I'm ready to send in the draft after this Zoom, but I have no voiceover for it. I just wanted to see where we're at.
No. I do not want voiceover yet. I just want draft presentations. And then next step, that's why we have this next week. I want all the presentations in, and then the next step is making the video.
Oh, okay, cool, thank you.
So the paper, electronic presentations, and then the video. Okay.
All right.
So we at least have one back and forth, and I see what you got, and you have some time to revise it, or add on, because sometimes I see, could you do a little bit more research on this, or can we show a little bit more how that would look in detail, like how are the medications functioning in detail versus just they do this one thing or so? Because I when I read it, I kind of try to look from a fresh eye as well and give you feedback on that. Okay.
All right, cool. Thank you.
Anybody else in this discussion that has questions or comments, please?
Yes. So you just want a draft of everything that we're planning on using, but not the PowerPoint? And
no, pictures? I want the PowerPoint.
You want the PowerPoint too?
I want the draft PowerPoint or Google slide presentation.
Okay.
And then I comment or feedback you guys on that. I read it and I see, hey, how does it flow? How does I filter it through me, give you feedback on it, then you guys can revise it or add on to it. And then the next product or the third product, we can make a video with it.
Okay, thank you.
And uploading, use the Canvas if it's a group presentation. I've never done group presentation as an upload yet, so I don't know if you have individual presentations, if it still eats other people's. So if you have a group presentation, go to Canvas, do it that way. That's the best. But if you don't have group yet, just individual, just shoot me a Pronto or a Canvas email with it. All right. And then I'm not giving anybody points yet. Don't worry about points yet. We're just working on it. All right. The points come after. Don't worry about the points.
Professor?
Just worry about doing it. Yes.
I have a question.
Yes, Jocelyn.
So what's due on Sunday, April 24th?
The
What are we
slide,
turning in that? The slides.
the slides. That's the last
Got
day
it.
I want to see the slides.
Okay.
But if you have something before then, I've worked with some of you already. Please turn it in as soon as you do, because then you can start really work on that editing process already. Because then I gave you 2 weeks after the 24th to create the video. And if you put everything, you know, all the editing and making the video in that 2 weeks, it gets a little crowded. So give me what you got when you have it, okay?
Got it.
All right. Anything else? Oh, and the references. Somebody asked me about the references. Put them on the end. Just put copy those links onto a page at the end as references. And, put a picture of a library on it or something. Always use pictures. That the common consensus is, the common feedback is, take away all the ands and buts and ifs on the language and just stick to bullet point important words that you can use, that help you making the lecture, that are your flashcards to convey the information. And then the teaching, you do as much as you can with pictures. Because the pictures is what's going to stick in our head when we hear it, when you tell us about it. Think about, most people, you think about what's the worst thing to do is read a friggin' textbook with no pictures. A novel is fine because you can make the picture, but a textbook with all those, all this language that doesn't really mean anything unless you really think about it hard. They're all foreign words. It's the hardest thing. And so visuals really help with that. And so keep that in mind when you make your presentation.
Is there a limit on the amount of slides that we can use? I'm not sure if
No, not at all. Generally speaking, you want less info per slide and more slides versus cramming it in.
Oh, okay. I got you. Cool. That'll work.
At the end, I just want the video to be of a whole group to be like, try to stick with 5-ish minutes. And so like, depending on how because our attention span is not that long, so it's like, you see it with, even with my videos, the voiceovers is like, I don't know, you let me know, but actually that's a good question, because when I make my new voiceovers, I want to make the length right, because, when is your falling asleep factor? When is like, oh, this is getting long now. When you watch my videos, think of when that happens, and since that's how long you kind of want that video to be. You don't want it longer than that. And so as teachers, what we're learning a lot, or what online teaching is really challenged with understanding, is cognitive overload. It's like, how much can we take in one setting? And so, learn from when you take my videos or so and say like, oh, I'm falling asleep now. Well, that doesn't mean you shouldn't fall asleep. That usually means I'm talking too long. So use it from that. So I think about 5-6 minutes or so per presentation per group would, I think, be ideal.
Nice.
Yes, next. Yeah. Anybody? No, good. Well, you can keep speaking into me when something comes up as a question, but work on that presentation, follow your interest in that pathology, spend some time with that, or as much as you can, and let me start going through what we're doing this week. And again, if you have any other comments or questions, please just speak up. You don't raise your hand. I don't see your faces at this point now, because what I'm doing here is I'm going to go through this week. We finished up with the endocrine and tegumentary and nervous system basics. Do you have any questions to those? How was that? How was the nervous system stuff? Did you get that? No problems. Okay.
Yeah, no, it was good. It was pretty easy to go through.
Okay. Good. Yeah, the endocrine integumentary is very straightforward. It's the nervous system basics. You see electricity. Sometimes that can pose a little bit of a challenge. So make sure you reach out to me if that is for you, and we can speak a little more now or offline, or make a second, a tutoring session out of it or so.
Yeah, voltage measurements, electricity stuff can get a little stereo destruction sometimes, but
yeah, it's just, and at the end, again, it's almost like, we're using these terms and we really just want to visualize something, and in a nerve impulse, really what you want to visualize is how these molecules, these ions are charged. So you got these two things. You got these chemical pieces, these ions. Where the heck was that? And then you got the charge on those ions, and then they move around and they carry a charge with it, and that's when it becomes electrical. And that's when the charges that go in and out, wherever that is, how we then measure that, the charges that go in and out then create this internal change of electricity, and that just is really a signaling device, right? It's like Morse's code or something. It's an on and off switch that we can use as a language, and so then that is used as that electrical language to transfer, single information, on and off information pieces, like in a computer, which is kind of interesting, from a long distance, like the little finger at the end of your, thing at the end of your finger, to the brain, and very fast. And so that's when we use that electricity. So it's pretty interesting stuff. So if you want a tutoring going deeper into that, reach out to me. We can organize that. If not, that's great. If you understand it, that's great. And again, as a reminder, when you study for this material, and it is a lot, and we go through it, keep in mind the test review, and go back and look at the test review where we talk about all what's testable in these chapters. And so you don't need to know everything about all the nervous system stuff. What we did last week, you need to know these points for the exam. And I want to make sure you understand these points. If these points are gibberish to you, then we got to talk. All right. The rest of it is all, of course, it's all important. It just gets overwhelming. And so I don't want to be too crazy, but with doing it this way, I can expose you to a lot of material that I think is really cool stuff, and I can try to teach you as much as possible without, making you go freak out because everything is on the test. So please keep that test review in mind. Print that out. And again, it's an open book test. I don't believe in closed book tests because you're learning, looking things up. So make use of that. Organize your material. Don't just throw the stuff out afterwards. Use your material for the next learnings that you're doing. Anyway, that is my little gibberish. Hello. Hello, put you on mute. Thank you. All right, sorry about that. All right, so this week we're going to talk about the brain. We're going to have little objectives on it that you can go through yourself. We'll not have too many activities, not too many assignments. I want you to work heavily on the presentation. We have one question set on the brain. It's a lot of questions, but it's just one set. We have one labeling. It's a fair amount of terms, but it's one. And then we have a health kit integration exercise that we use. So looking at the brain itself, we have some videos, blah, 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 blah. And then on the concepts, we go into the bigger nervous system. So we learn about how the nerve looks on the microscopic level and how it functions as an electricity. But now we're looking at the whole nervous system. So we're looking at the divisions first. We're looking at the brain and the spinal cord, which is the central nervous system, CNS here. So after central nervous system is defined, I'll call it CNS. It's a few of those abbreviations I use. And that's the brain and the spinal cord. So first we're going to look at the brain in this chapter now, but But the nervous system itself consists of the brain and the spinal cord, which where we make most decisions for the body, and then it has we have a peripheral nervous system, and the peripheral nervous system. Let's see. Do I have a better picture of that? I think not. I have to use on this slide. I have to use all these open source pictures, so I don't have a better one on this. But the peripheral nervous system are all the nerves in your arms, in your legs, around your chest, and all the ones you feel when you cut yourself. And so these are all little cables that go in and out of the brain. And I say in and out of the brain because the nervous system fundamentally is organized that you have receptors on one end of a nerve, something that, or not every nerve, but many nerves and peripheral nervous system, like a receptor that picks up some energy, that picks up either a muscle stretch or it picks up a pressure or a temperature change or something. And then at the other end, you have the spinal cord and the brain that integrate the information that is brought in to the system from the outside or the inside of the body. A chemical can be measured inside a blood vessel, for example, and send that information to the brain. And then the brain processes it. Some of it is processed at the spinal cord level, very rudimentary down at the spinal cord. And then once the information is processed, you have an output. You have a nerve that brings an effect out, and the effects usually go. They always go to another nerve or to a gland or to a muscle. So you have a change in the environment from that. For example, if you touch a stove that's really hot, and the information of heat goes into the system, the spinal cord at that level and the brain secondarily will make the muscles work that retract the heat, the finger from the heat. And so that's sort of how fundamentally the nervous system works. You have something being detected, information going into the central nervous system via the peripheral nervous system, and then from there, once it's processed, the output goes back out via the peripheral nervous system to the organs that need to make a reaction, make a change. All right, that's a lot of chattery I'm doing here. So that's firstly, we talk about that a little bit. We get into the brain development a little. So that's kind of interesting. Not too deep, but fundamentally how we're made, how we have we're sort of a leaf. I often visualize it as a leaf, or like a leaf, and in the inside of the leaf you have the stem that goes up and down, and that stem becomes the spinal cord, the neural tube they call that ultimately. And at the end of that stem, so then you turn the leaf upside down, at the end of that stem, which is then here visualized, these blow up a little bit, and these vesicles, they call them primary vesicles, and they become the brain. So here we got then the brain stem at the bottom here. Actually, even the yellow one is part of the bottom brain, the hind brain, that's like partly almost like our spinal cord, where we have, like, when you touch all the way by the skull on behind the ear, right at that level, that's sort of like around here in our adult brain. And then the majority of the brain, the wiggly stuff that you can see as a brain when it lays in the gutter, I don't know, you just see a brain, is actually this stuff here, the cerebrum. And so that's sort of the development, in fast, but the most important sort of points. It's interesting, the brain starts developing when the embryo is 18 days old, not even 3 weeks, which is kind of sensible because who organizes everything else? So you got to have a brain first, and then you got to have a heart to get energy into places, and then you can start making stuff. So it's kind of like, even you think, when we do at the end of the semester, we talk a little bit about embryology. You almost got to like think logically, how would you make a body? How would you create that? And so the brain development starts very early on, or the nervous system development, I should say. So that's kind of cool. And then we'll have a little bit of time on the protection of the nervous system, or of the central nervous system. So the brain has, and the spinal cord, they have skins around them. They have a very fine skin that oh, here, actually, that is called the pia mater. That's like shiny. When you see a brain and it's shiny, that shiny part is a membrane that lays right on top of the brain, and that's a layer of protection. And then you have a second layer of protection that has little spider webs going around, or webs going up and down, and in between there's a space. And the webs are actually interesting. They're holding the brain to the skull, or the outer membrane that then, it's not the skull's out here, but then the outer thicker membrane, the outermost membrane is very thick. It's like leather almost. It's, very thick, more white. It's more tendony, but it's leathery, it's strong. And so, so that's, though, the middle layer attaches the brain to that membrane and creates these spidery webs. So they call that actually the arachnoid motor, which is spider, arachnophobia, right? Arachnoid spider. So when you look at terminology, you want to slow everything down and think about it a little bit, or process it, because it's very overwhelming, all this material, but it's fairly logical at the end of the day. And what's really cool in between here, in this space that is created here, first of all, yeah, the brain is attached. And, this is very important when we talk about concussions, for example, because they were thinking about concussions, and I don't know if it's all one way or the other, but first, concussion is when you hit your head really hard on something, right? You like slam it down to the ground or something, or a car accident and a whiplash back and forth really hard without hitting something. That can be a concussion too, because the brain is very plastic. It's very moldable. It's like jello. Like if you actually hold the brain in gravity that's alive, it would fall, it would like collapse. You can see that sometimes when that liquid goes away that's around the brain. And so it's very soft. And when we have a concussion, the hit actually slams the internal, more jello-like structure towards the skull, and that causes bruising, and that hurts the brain. But the other thing that we're learning is it also pulls the brain away on the other side, where the hit comes in from, well, actually, I don't know those dynamics exactly, but on some areas it pulls it away, and that causes a lot of brain damage. So that disrupts this situation here. And so because in between this membrane you have liquid, and the liquid is the cerebrospinal fluid, which helps the buoyancy, helps the brain be weightless. So it's like the brain is actually always swimming in a pool, like when you swim in a pool. That's the environment for the brain. It's weightless in there. It's got much less heavy than if it were in gravity without that surrounding liquid. So that's kind of really cool. The other thing the cerebrospinal fluid does, which is actually a whole section here, it supplies the brain with nutrients and feeds it. And so some of the thinkings also with Alzheimer's stuff, well, that's less the cerebrospinal fluid, but it has to do with cleaning the brain out at night. But that's a different topic. Anyway, then what we do from there, we move into the main wiggly part of the brain that we can see. We talk about this white matter, gray matter. White matter are these parts. When you cut it open, you can see a white stuff here, and then the gray matter is a little darker, as they call that gray matter. Gray matters are cell bodies. So they're sort of the processing centers. You can think of that as cell bodies. And white matter are extensions. And those are, last week we talked about the neuron, right? The neuron has dendrites and has axons. And so those are the extensions. And that's white matter, and described in white matter, because a lot of the extensions are covered by a fat layer. That's the Schwann cell, the myelination. That was in the last part of the chapter there, I believe. The Schwann cells create that wrapping, that fatty wrapping that then speeds up the nerve impulse. And that's what you actually see makes that tissue white, or whiter, because it's the adiposity. Anyway, not adiposity, just the fat. All right, the fat wrapping. Blah, 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 where we are here. So, and then we talk further, we go a little bit into the hemispheres, we go a little bit into the tracts of how different neurons work with each other. We have two hemispheres to the brain, a right and the left. You often hear people talk about, I can be more logical, or I'm more artistic-y. That's a line on the left, but don't be a little careful about that. But they both mirror each other, those sides. They do have some complementary tendencies, but there's not like black and white like that. But it is interesting to have those things, but we have to be careful about the globalizations. The other thing I think we have to be even more careful is when people say like, oh well, I'm just not good at that because I'm not logical because I'm left-brained or right-brained. I never even remember how it goes. But what's most not good about that is the fact that the brain is very plastic. The brain can actually learn extremely well, which you actually see this semester because you're learning a lot of really new stuff that hopefully I think you find kind of cool. And once it's kind of feels like it's kind of cool, even though it's painful to study all these new terms, but if it's sensible and you have some drive with it, the brain actually picks it up really fast. And so the brain is very moldable and functional and learnable. So that's really, I think, what the danger is, that we don't use those left and right brain hemisphere things as excuses why we shouldn't do something. I think an excuse why we shouldn't do something is more like, I don't find it interesting. That's more, I think, personal. But anyway, next after that, sorry, I'm a little chatty here, even though I only have one coffee. From that bigger picture talk of the cerebral cortex, the outer shell, we go into the different lobes and describe the different lobes of the brain. And as you can see, look at that. We have a frontal lobe, we have a parietal lobe, we have a occipital. These are all like the shell, like the skull plate. So actually they mirror that. So we have these lobes are representing different parts of different things that are happening in these different parts of the brain. But it's very interesting and it's very sort of diffuse, even the way I tell you. I'm sure you go like, you're not that clear of how you say this. And the reason why is because we have an incredible plasticity to the brain that we have found ways, for example, to help people who have vertigo, don't have vertigo and can dance. Vertigo is like your room spinning. You like don't want to get out of bed. And they give them gum that irritates the tongue in different ways when they move, and the balancing goes on, and they move sideways and they spin and turn, that it reprograms their brain that they can dance again and spin around, which is like, hell no, when I have vertigo, I don't want to do that. If you don't want to know what vertigo is, you just, on your own cognizance, you spin around in a room and then stop and the room starts spinning a little bit. The people with vertigo always feel that. So that's, brain is very, very plastic. And so that's why I'm a little diffused. But we have areas that mostly do certain things, but other areas are capable of helping out and taking over those functions. And so we describe frontal lobe generally has to do with speaking and thinking, motor commands, working memory, judgment, etc. Yeah, I mean, if you smack yourself on the front end hard enough, maybe then your working memory might go a little, well, not so good, or your personality shifts a little bit, or if somebody has a stroke in that area. But certain functions can be then taken over by other parts. They've seen that, for example, one function that we describe heavily is to speaking is Broca's area, which is one of these brain areas are described here functionally, and they're called the Brodmann's. Oh, look at that. I misspelled that. It should say Brodmann, B-R-O. Brodmann's functional areas. And one of the one that is most interesting is the Broca's area, which I can't even, oh, here, Broca's area, right here. And that area has to do with speaking. And if people have a stroke in there, they can't speak anymore because the brain dies in there. But they have found that if they play music, old songs from their childhood to those people, and preferably, of course, in person, because then they have some personal connection to it, they can pick up on the opposite side, the mirror side of the brain, that area, and start speaking again, not as logical or not as structured. There comes the logical, a little more gibberish or so, but they can, which is phenomenal. If you think about it. So you can trigger different areas to get elicited and and take over things that our other areas can't do so well anymore. So that's really, really cool. And that speaks to neuroplasticity of the brain. Anyway, we go through all these areas, do all that stuff. Look at that. That's pretty neat. This is really freaking cool. You have this area in the brain here, this green one and this other green one, bluish one, where you have a primary motor cortex or a primary sensory cortex here. So you let me back up a little bit. If you look at an part of the brain, let's say that parietal lobe, the parietal lobe on the side above the ear, is responsible to help us experience the world through physical sensation like touch and temperature and pain. So not like hearing or seeing, more like these other ones. And this is where we experience those feelings consciously and then process the meaning of them and then create an output and figure out what that means with it, for example, so we can think about them. So what happens in an area, so this is this area of the parietal lobe, more or less. What happens in that area, we have this place here, the primary part of the cortex. Here it's called the somatosensory. That's what the feeling like touch and temperature, what we call that. Somato is body and sensory is feeling, sensation. And that's where that comes in as an impulse from the body. And then from there, we go further into processing areas and process the meaning of what that impulse means. And then from the processing areas, we can then get back to then a primary area. Actually, the feeling processing happens here. Hey, what does that mean? Did somebody touch me lovingly, or did he slap me? Or, what does that mean? What happened right here? Or is this too hot? Or am I going to be okay going under the shower right with this heat? Those are the interpretations of that sensation that are processed here. And then we have to send an impulse here to the frontal cortex, because the frontal cortex has to do with doing motor commands and so forth, and speaking and all that judgment stuff. And the frontal cortex then will say like, well, it's too hot, this water. Let's turn it down a little bit and make it cooler before I burn myself when I go under it. And then that's where then the primary motor cortex is the last place that sends the signal to the muscle that will move and turn the knob down that will make the cold motor cooler. Does that kind of make sense a little bit as a bigger picture? Anyone?
Yes.
Good.
Yes.
All right. I don't want to hold you much longer. Just give you an overview, because this stuff is friggin' interesting. It's just a bit complicated, but not really when you go deeper. And so these are some of the general ideas. And so when we look at the lobes, then so we have the frontal lobe is that motor, the function, the thinking kind of lobe. The parietal lobe on the side above the ears, where the parietal part of the brain, the skull is the more the feelingy, the sensation lobe. And so, and then this is where I was going to. So then when you get to that part here, that somatosensory, that primary feeling place where the impulse comes in, you can actually map the darn thing out. And you see, this is the inside part of the one brain hemisphere. This is a brain hemisphere. This is the other side of the brain hemisphere. And then you can, on the inside, you can see you get the genitals, you get the leg, you get the trunk. You can see how much space is dedicated to the hand. You can put your hand in your pocket and you feel some coins and you can tell which coin is what. That's remarkable. You can't do that on the back. And so you can actually realize when you look at that, you say like, wow, look at the thumb. It's got so many sensation nerves in here. So you can see how much space is dedicated in the brain to that area of the body. So that's kind of cool. So they call that the sensory homunculus, that thing. The tongue's pretty good. Look at the lips are pretty good too. Anyway, you have that on the sensory side, where the parietal lobe is right here. But you also end up having that in the primary motor cortex here as well. You have the same thing. I just didn't put it up because there wasn't a picture, I don't think. But it's the same kind of thing. And it's just then called the motor homunculus, not the sensory homunculus. And so the frontal cortex is sort of the main motor, the main doing, the main thinking, the main like that cortex where your conscious thinking happens. The parietal is the general feely thing. Then the occipital is primary visual. Oh, the parietal also holds the taste buds. So when you taste salty or bitter, so it's in there. Seeing primarily is in the back. Hearing primarily is easy. That's right behind the ear. And then we got one extra lobe. It's called the insular lobe. And behind the ear, you actually pull that apart. You have an extra wiggle in there. And that extra wiggle, let me see if I can see that wiggle. Yes, you could see the wiggle here. This is actually a slice from the side where you, right, it's sliced right through here, there, right? And so you can see that wiggle, but what, I mean, that primary somatosensory cortex, but you see here, there is another space in here that we have not defined yet. And that's called the insular lobe. So that's kind of hidden like an insula, like an island. So that's why it doesn't have a skull plate, because there's no need for a skull plate. But that's also a lobe, and that has to do with balance act. So that's an interesting place to balance act, also self-awareness, and is linked also to emotions. Well, yeah, we have these external lobes, but then also we do have internal parts, which we'll talk about briefly, that will have other functions as well. Oh, look at this. I should have gone all the way to the bottom. This is where it explains the primary areas and association areas that I worded before. So it's just a picture for that. So go through that again. Sorry, I should have used that picture. There are the lobes, and then we have these other structures that are below the surface that we can't see from the outside. And so these are known as nuclei generally, although it's kind of funny. The first word here is ganglia. Nuclei and ganglia are the same thing. They are clusters of cell bodies. So the gray area here, gray matter, that's actually clusters of cell bodies. It's just on the outside, so we don't call it anything else. But when we go deeper, we have fibers, we have this white stuff, this myelinated axons and dendrites. That's inside. When we then have clusters of cell bodies, they become centers that are grayer. So they're not white matter. They just color them here. They don't look like colors in the brain. They're just grayer structures. Well, actually, some of them do have a little bit of color because of the neurotransmitters in it. So some have a little differences. But then we call those clusters either nuclei or ganglia. And traditionally, that's been interchanged. In a more modern anatomy language, we try to call everything inside the brain and the spinal cord a nuclei, and everything outside a ganglia. So newer books will call this a basal ganglia, and older books will call this a newer books are basal nuclei, and older are basal ganglia. And I should actually put a thing here and say both. So I just want to point that out to you, because what I hated about these things, and I'm a little picky as a Germanic on that, is inconsistencies. And so I try to clarify those as much as I can. So anyway, we have these structures on the inside that do things that are nuclei. So when you think of nuclei or ganglia, these cell body structures, you think of doing things. And so the basal ganglia is really cool, because that helps us with learned body movements. And so when you learn how to play the piano, or drive a car, it's gonna be in there stored, that miraculously, not that you should, but you could do all kind of stuff driving a car, because you're actually now really good at it. And it's all learned motor patterns and movement patterns. That is also why it is important to, when you, for example, learn how to play a piano or do some sport, practice makes perfect is more practice makes permanent. And it is helpful, I think, in trying to learn it proper the first time. I mean, you don't have to, but that's just one point for it. So just when that's like comes into play, like getting the kids some piano lessons, or I don't know, stuff like that. But anyway, that's just neurologically why there's a difference between that. Because you create stored movement patterns regardless, obviously, if you learn it wrong or right, or easy or hard. So that's kind of cool. So for us in a walking position, for example, we need do some day-to-day things, and we walk. Walking is in there, not just driving a car. Walking is in there. So we actually walk. The top head of the brain, oh, it's gone now. The primary motor cortex doesn't need to move every muscle that walks. It just needs to send a signal, we're going to walk. And then the basal ganglia has all this movement of which muscle to contract when, that we actually ambulate, which is really complicated. As you understand, when you look at the development of robots, robots are not really walking that easily. That's a hard thing to walk with 2 legs and not fall over. And so give your body some kudos just for doing that. Anyway, so that's basal ganglia. Then we have, of course, smelling is a cortex inside. But the other thing that's really cool is the limbic system. The limbic system is our emotional brain. So the limbic system is where we feel emotions. This is where we have a freak out, or where we feel comforted and have feelings. And so, it's very interesting. And one of the things that's really fantastic, I think, is the knowledge that the limbic system is directly related to the olfactory cortex. And the olfactory cortex is smelling. And so we know neurologically that, and that makes sense, because if you look at the lower level animals, a lot of them get through the life by knowing what to smell and how to smell fear or danger, and then they can have a response to that. So we still have that part of the connection. We just don't have, obviously, that strong of a smell like some other animals do. But the other thing that's really cool, so use, lavender, use rose things, if you like to use aromatherapy for your feeling states, for feeling calm and all that, or energetic, there's your scientific evidence that that's going to work somehow because of that direct link. So it doesn't have to be processed at all through the brain, frontal cortex of the brain. Anyway, that's kind of cool, I think. And the other thing that's kind of cool here is the amygdala. And I don't know if you ever heard of an amygdala hijack. And the amygdala hijack is when somebody freaks out. That's when the kid has a tantrum, or the adult has a tantrum too. And so it's interesting how, but also that, of course, happens. It also impulse, crap happens that we don't want, and we want to have not happen later on. We regret. And that happens in that deep emotional part of the brain that evaluates things, danger or non-danger meter. It's right in here, deep in it. And if it reacts and we can't stop it, it can overpower our top brain, our thinking brain, and just then we all had those things happen. And it's like, afterwards you go like, it really wasn't that important. But in a moment it is. And so that's an interesting thing to understand, because we can start talking to if we understand our brain, we can start talking to our brain. There was a very interesting doctor, psychiatrist, somebody who talked about breakups, and they talk about how that's kind of like people, are addicted to cocaine when they have a breakup. That's how painful it is, and how the brain needs to be supervised. Like if your brain goes into crazy thinking of the person that left you or whatever, then you have to occupy that brain and not just go down the rabbit hole and look at their Instagram. You have to be in charge of the brain as well as you can. It needs constant supervision. The word used was constant supervision. That kind of stuff. That was kind of interesting. And so in terms of the amygdala, if we can go and recognize, oh, that is just a reaction of my body. If I have a freak out, I can take a deep breath and slowly bring down the tension and bring it to what we then call the thalamus here, and more into the consciousness. Thalamus is a place that we also have somewhere. That is part of the mid part of the brain that then further goes down to the lower part of the brain. But it's a part where we start understanding things consciously. And so that's like one book that I read, it talked about, oh my God, I can't handle it when it comes to me. And then I have to take a deep breath and it brings it down. And that was, that person who wrote the book was in the Christian faith and brings it down to, oh, Jesus. And then at some point you get help from all these different sources that you have in your package of help in your faith. And then you finally can start thinking about it without reacting. And so that's, I think, interesting. with that, where we call that an amygdala hijack, when that brain takes over and we just have a freak out. And so that's interesting, partly interesting with the limbic system. So think about that a little bit. The other thing in the limbic system is where we store memory. So that's long-term memory. So this is interesting how that works with this process of the more a nerve pathways activated, the more stronger it gets. The more, and that happens with the hippocampus. The more that we use that pathway, the more it gets stored in a hippocampus where the memory is. And so that's another reason why flashcards work really well, or anything where you search for an answer in your brain, which is that little painful thing, but that creates that strengthening process. There is your scientific, well, I don't know if it's scientific. Cingular gyrus is another internal structure that's funny because it kind of has to do with gestures. So if you have a person that uses a lot of gestures talking, then they have an active cingular gyrus. So some of the brain is connected, and some of them is just tidbits that we pick up, because it's a very complicated thing to study our own thinking system. It's not that easy. And then we get into the hypothalamus, and that's really cool, because the hypothalamus is where we connect the emotional brain with then the pituitary gland that we talked about in the endocrine system. And then from there, it connects to the physical body. And so this is where the connection between the emotional brain and the physical brain happens. So that's kind of cool. Let's see, that should be actually on the diencephalon. Here we go. That's part of that. And that's then, that pituitary gland. Anyway, I think that's really cool. So go through that a little bit. So we did the lobes of the brain, we did the deeper structures, say that subcortical structure, because it's the cerebral cortex here, cortical. And then the diencephalon is the deeper brain, where the information coming up gets filtered in the thalamus. Thalamus is like a relay station, a filtering place, where it's like, hey, some touch goes here, some vision goes here, that's what happens in there, more or less. And then a hypothalamus is neat, because it's, again, that connection between the emotions and the physical body. So that's really cool there. And a lot of functions happen in the hypothalamus. You're going to have a whole list of that thing somewhere. Not sure where that is. It's very cool. And then from there, we talked that cerebrospinal fluid. I already briefly mentioned that, how that feeds the brain and makes it weightless. And then we move into the brainstem. And that's we think of that as the salamander brain. That's a very reactive, unconscious part, where we have a lot of reflexes. Like in the midbrain, for example, the cool thing about that, I think one of the cool things is we have these 4 bumps. Where the heck are these bumps? Here, look at these bumps back here. We have a superior and an inferior colliculus on each side. And those are reflex centers and we can relate to those because that's why I point them out, because they are reflexes to the peripheral vision and hearing. And so if you see something in your peripheral field, they react and get stimulated, and you look at it. Or if you hear a buzzing, like, a mosquito or some crap, and you hear it, you look at that, and that's happening in here. So that's kind of what sort of helps me understand something that happens in this very unconscious part of the brain. And then the pons is cool too, because it's connects. What we haven't talked about is the cerebellum. See here, that's the last thing. The cerebellum is the hindbrain. We call it the balancing brain. So this is where we balance. But we also do know at this point, there's also much more happening with planning and coordination and execution, stuff like that. Very interesting stuff in here. This brain has as many neurons, they say. No, that must be, because I read in a book. Has as many neurons as the main brain, the cerebrum that we just talked about. So it's really complex. But the pons is a little swelling. Pons means bridge. And that's the bridge part here. And it's a little swelling that has a lot of connections going back into the cerebellum and forward. And so so a lot of in the pons is a lot of tracts, a lot of nerve pathways going in and out. And then the medulla, in the medulla, we have a lot of, what is down there? a lot of reflex center, like breathing and heart and stuff like that. A lot of very unconscious things, you know, how deep do we breathe? How fast do we breathe? How fast does our heart rate goes? Et cetera, et cetera. We know the heart is controlled internally by the heart, internal in the heart muscle, but the brain influences it. And so that's happening in here. So that's really cool. Anyway, so that is pretty much that chapter. Sorry, that took a while. Was that helpful or was that too blah, blah, blah-ish?
No, that was good.
It was helpful.
Yeah, it was helpful.
All right, then I'll keep that as a path. Make sure you tell me to go through it a little bit if it helps you. Because I always feel like especially when I just talk to the computer, I must be careful not to be too boring. And if I am, let me know. This is the chapter where we label stuff here. So you could do it in here or you could do it externally. I have a few videos. I have a couple, I think. Oh, these are all the terms that I want you to label. And then these are the videos that explain the terms. I think I have, in the test, I mainly use a brain like that, which you can see on the pictures in the test review, which I don't put up yet. I should. Slowly we'll start. Once we get through the brainish stuff, we start doing labs again and prepare you for the final in terms of the terms, but not yet. It's a little too far away. But this is also a nice brain where I go a little bit deeper. So some of the terms might be more terms in the videos than here. Just make sure you only label all of these. You don't have to label everything that's in the videos. I hope it's not too many differences, but it takes a long time to make these videos. So some of them are older. This is all the other stuff, study tool. Okay, that's all we need here. There is no questions here. It's just a labeling thing and a coloring thing. And then, hold on, stay on the page, stay on the page. And then the next thing I want us to do is me just look through the gratitude journal. Leave page, okay. There we go. And the gratitude journal, well, there is this guy, and actually it's Easter yesterday in Switzerland, where I'm from. A lot of the holidays are still based on the Christian holidays, and so this is a big one for a lot of religions, but there's always reflections in the paper of some religious folk talking, and it's very interesting. And they talked about how people, a lot of times, if we hope for things, it's like it's good, but it's like we have this deficit. It's a deficit feeling. But if we have gratitude for what was, what we saw, what happened, it creates a fulfilled feeling. And so that was an interesting way of putting it. I really liked in the title. I can't read all these articles because they're all subscription, and I'm going to pay for that right now. But then there's this other guy from Austria, and he is a priest, as you can see, or a monk. Actually, not a priest, a monk. And he has a TED talk and says, want to be happy, be grateful. And so I figured, since we're talking about the brain, and you know, I'm happy, unhappy, anxious, that's a lot going on these days. I figured it might be good for us to do a gratitude journal. And so for 1 week, and so it has been shown, there is a place, UC Berkeley. I got this from UC Berkeley. Did I put an external link on here? I think, did I? I didn't. I got this from UC Berkeley. If you want more of these kind of things, you know, reach out to me so I can give you the link. But what they tell us to do, what helps with happiness and increased happiness, is at the end of the day, think about a few things that made us happy during the day, and it doesn't need to be big. That's the funny part. When I was very depressed because my family took off, and never mind, we don't have to go into that, but it took me a few years to get back. At some point, I picked up a book and it says, you know, gratitude makes you less depressed. And I read it and it was like, be grateful for the sunshine. I'm like, sunshine, grateful, what's wrong with, no, that's like, I'm depressed already. That's, you know, but that point is thinking about those kind of things, or the flower that smelled, or the smile that you got, or whatever it is, the good taste in coffee. When you reflect on that and you relive the positives a little bit like that, it slowly changes the brain to focus on those things and makes it more content. And so I want us to, for 5 days, at the end of the day, write out 5 things or more that you had during that day that made you feel that way, that made you feel grateful or thankful, and cherish those for a moment, relive that moment for a moment, and then do that for 5 days, and then see how that made you feel, and then we have a little discussion over that, how that made everybody feel. But that's sort of where I feel that we can sort of experience the brain a little bit, and it's an exercise that seems very helpful. And I've been seeing more and more podcasts in positive living, things that I follow here and there that integrate those kind of exercises. All right, so I want us to do that. Does that make sense to you? Do you have any questions on that?
Yes, makes sense. Thank you.
All right. Any questions, comments? No? Oh, good. If that's the case, we can go off the week, and I really appreciate your full attention for that long. And go a merry way, and reach out to me if you have anything. I'll stick around a little more for you guys if somebody wants to have questions.
Yeah, Dr. M, I have a question.
Yes.
For the presentation, I came in late, so I didn't listen.
That's okay. That's
early. Okay, how is it? When is the presentation?
So the presentation, the written one, the one that you're working on now is the text and the pictures. Send me that as soon as you have something, so I can give you feedback and I can work with you on that. And review this recording. Well, obviously, if it's a recording, you're already going to review it, but listen to it when I put it up in the beginning. I'll talk more about it. But send me that as soon as you can. And then that's due on Sunday, this coming Sunday.
Okay, and then then we can record it and send it
and
to
that's
you,
afterwards. Right? Yes, and then that's afterwards. So send me what you have. Once you have a draft created, send it to me so I can start looking at it, so we can work on it. It doesn't have to just be by Sunday, because the latest I want something by Sunday. But if you already done some revision before then you're better off, because then the next step, once we've done revision of the presentation, then you create that voiceover video. And then that's due not this week, that's in another 2 weeks.
Okay, got it. Voice over the video, so if that day, if I'm not available, it's okay, right? As long as
it's not a live thing. It's not a live thing.
Okay.
You do it in your group on Zoom through the homepage on my class. There is a Zoom group. Are you seeing my screen, or you don't see my screen?
Three. Wait, I think I already did mine. Yeah.
Okay. No, then you will be okay. But the text part latest is due on the 24th, and then the video latest is due on May 8th.
Okay, good. Thank you.
All right.
Thank you, Dr. M. Thank you very much.
You're welcome. All right. Anybody else? And otherwise, you can hang up, but I'm still here for anybody. I wish you a wonderful week. Enjoy your time, and make sure you go outside a little bit too, and do that gratitude journal. Get some things you're gonna be grateful about, huh?
Hey.
All right. Bye.
Thank you. Have a good day.
Thank you.
Thank you, Professor. Bye.
Bye.
Hello.
Mm-hmm.
Oh, okay. Okay.